Hi, this is Dr. J. Vikas Paul. In this session, we will discuss about unsymmetrical bending and shear center. So, what is unsymmetrical bending and symmetrical bending? So, if you see, let us take an example of cantilever beam. It is a fixed support, one side fixed and other side free. Other end is free. One side fixed, other end is free. Okay, this is shown in this way. Okay, and this is also the same figure, but the load acting on it is different. That means here the plane of loading, this is the plane of loading, it is coinciding with the plane of symmetry. This is the plane of symmetry. Okay, or we can call it as principal plane. Okay, here the plane of loading is coinciding with the principal plane yy. The load is coming on yy, but here the load is not coming on this yy. That means plane of loading is not coinciding with the plane of symmetry. Plane of loading is not coinciding with the, see, this is the plane of loading, this line, it is not coinciding with the principal plane. Okay, in the previous case both these lines are same. Okay, see, this one is coinciding with yy, this is not coinciding with this yy. Okay, that means the load is inclined, it is inclined at an angle of theta with yy. Okay, so this case, the bending in this case is known as symmetrical bending. The bending which is in this case is known as unsymmetrical bending. So due to this load there will be some deflection. This bending is known as symmetrical bending. Due to this load there will be some deflection. This is known as unsymmetrical bending. Here you can see xx will be shifted to downwards, but yy will be the same. Here after bending xx will be shifted to another position, yy will be shifted to another position. Okay, in symmetrical bending, plane of loading, this is plane of loading, coincides with the principal plane yy or plane of symmetry. Bending will occur only about x-axis. Bending will be occurred only about x-axis, not yy here. In unsymmetrical bending, plane of loading, this is the plane of loading, is plane of loading is inclined to principal plane to yy or plane of symmetry, but passes through the centroid. This passes through the centroid and this also passes through the centroid. Okay, so bending occurs about x-axis and y-axis. In this case we'll take stresses about sigma equal to sigma bx plus sigma by, both the axes. Now let us see formulas. First of all, center of gravity formula x bar y bar equal to a1 x1 plus a2 x2 plus a1 plus a2, a1 y1 plus a2 y2 plus a1 plus a2. This we know. Moment of inertia about x-axis, ixx equal to ix1 plus ixx1 plus ixx2. What is ixx1? ig1 plus a1 h1 square. Ixx2 is ig1 2 plus a2 h2 square. In problem, we'll see in detail what is this one. Similarly about y axis, iy1 plus iy2. i1 is ag1 plus a1 k1 square. Here a2 k2 square. Then product of inertia formula ixy equal to a1 h1 k1 a2 h2 k2. Then position of principal axis, tan 2 theta equal to 2 ixy minus iyy minus ixx. Then principal moment of inertia formula is, so ixx plus iyy equal to iuu plus ivv. Therefore from okay, but iuu is ixx plus iyy by 2 plus ixx minus iyy by 2 secant 2 theta. If you want to find ivv, simply write down ixx plus iyy minus iuu. Then you can find ivv. Let us see a problem here. The figure below shows an unequal angle. In this question, figure is not given. We have to draw the figure. Okay, by reading the question. Shows an unequal angle. Sections of the dimensions 100 mm by 60 mm. So 100 mm depth, 60 mm. This is 60 mm. And 10 mm thickness. Thickness is 10 mm, 10 mm, 10 mm. Determine first one, position of principal axis. Okay, we need to determine the position of principal axis. Then magnitude of the principal moment of inertia for the given angle section. So these two we need to find. We know the formulas. So to find this, we need to find ixx, iyy. That means everything we need to find. Okay. So first of all, we need to find the center of gravity. So we know this formula x bar is equal to a1 x1 plus a2 x2 plus by a1 plus a2, y bar equal to a1 y1 plus a2 y2 by a1 a2. Now let us divide this into given figure into two parts. This is one part, this is second part. Okay, now a1 is the area of first part. That means see, if this total is 100, what is this depth? This height is 90 mm. Okay, so 90 into 10, 900. What is a2? 60 into 10. Okay, a1 a2. Next x1. Now what is x1 here? Now if I take this as origin, x-axis, y-axis, x1 is half of the first one. This is first portion now. This is a half of the distance. That means centroid distance, x distance. So 10 by 2 is x1. Similarly, what is y1? This is first portion now. So this height is 90. So y by 2. For rectangle, we know that it is x by 2, y by 2, centroid. Okay, so y by 2, 90 by 2, 45. So x1 5 mm, y1 90 by 2, 45 mm. Then x2 means for second portion, from here it is 60 by 2. Okay, 60 exactly at center. Then y2 means from base we need to take, so 90 plus half of this portion, that means 10 by 2. 90 plus 10 by 2, so 95. So x y, using the substituting all these values here, we can find x bar y bar 1565. Okay, so this is x bar is at 15 mm, 6 y bar is at 65 mm. We can show in this way. So from origin at a distance of 15 mm, there will be centroid, and y bar from bottom 65 mm height it will be. Okay, so here centroid is in air here. Okay. Now if it is 65, what is the remaining height? 35. If it is 15, what is the remaining distance? 60 minus 15, 45. Right, next one, moment of inertia about x-axis. Moment of inertia about x-axis we need to find. So ixx equal to ixx1 plus ixx2. What is ixx1? ig1 plus a1 h1 square, ig2 plus a2 h2 square. Now what is this ig1? b d cube by 12, first portion. Okay, so b d cube by 12, d1 cube by 12. Then a1 h1 square. H1 is nothing but y bar minus y1. Then coming to second one, b2 d2 cube a2 into y bar minus y2. Now what is b1 here? b1 is 10, d1 is 90. Okay, a1 90 into 10. Then y bar is 65, we know. y1 is half of this first one height, that is 90 by 2 whole square. Then b2 60, d2 10 plus area 60 into 10. Then y bar you know 65, we know, minus y2. What is y2? From base 90 plus 10 by 2. Okay, 90 plus 10 by 2 is 95. So y2 95 square. Simplifying it, we will get the value as this one, ixx. Okay, so I have shown here y1, y2 and all. Okay, similarly calculate a moment of inertia about y axis. I1 plus I2, ig1 plus a1 k1 square, ig2 plus a2 k2. So here the formula is db cube by 12. Okay, it is reverse here. So what is d here? Depth 90 into for first portion. What is the depth? 90. B is 10. So db cube, 90 into 10 cube divided by 12. Then areas will be same, 90 into 10. Then x bar. What is k1 here? X bar minus x1. K2 is x bar minus x2. X bar you know. X1 also you know, 10 by 2. X1 is 10 by 2. Okay, so 10 by 2 all square. Next, for second portion, db cube. D is this one, 10. B is 60. So 60 cube. Okay, plus 60 into 10, area is 60 into 10. K2 x bar minus x2. X bar you know, x2 is for this second portion it will be 60 by 2. 60 by 2. So substituting this, we will get I by y as I by 1 plus I by 2 equal to this one. Next, third one is product of inertia Ixy. The formula here is A1 H1 K1 plus A2 H2 K2. We know that H1 is y bar minus y1, K1 is x bar minus x1, H2 is this one, K2 is this one. Everything we know. Y bar we know, y1 we know. Y bar, this is y bar. Okay, this is x bar 15. Okay, this is x1. This is x2. This is y1. Y1 45. Half of this 90. 90 by 2 is y1. Okay, and y2 from base it is 90 plus 10 by 2, 95. So substituting we'll get Ixy as this one. This is Ixy value. Okay. Then position of principal axis. Tan theta equal to Ixy by I by y minus Ix. This value you know, this value you know, this value we know. Substitute will get this one. Okay. So 2 theta equal to tan inverse this one. Okay. This is the theta equal to 70.36 degrees. Okay. Minus, that's why anti-clockwise direction. So here if you see, this is xx, this is yy, centroid is here. Okay, but it is rotated to theta anti-clockwise 70.36 degrees. Okay, so this is the xx became uu, yy became vv. Now principal moment of inertia about the principal axis. Now this is known as principal axis uuvv. Moment of inertia about principal axis uu is, the formula is iuu equal to ixx plus iy. This value we know, this value we know, this value we know, this value we know, theta also we know, 70.36. Okay, now substituting all these values we'll get iuu as this one. Now how to find ivv? We know that ixx plus iy equal to iuu plus ivv. We know this one. From here ivv equal to ixx plus iy minus iuu. This we know, this we know, this we know. Ivv is this one. Clear and sure problem. Thank you.